Right now, in Beijing, a small AI company did something that made engineers at OpenAI and Anthropic genuinely stop what they were doing and pay attention. They released a new AI model. 2 days later, they had to shut the doors on new users entirely. Not because the model failed, because too many people wanted in at once. So many requests hit their server simultaneously that the company had to pause new signups just to keep the lights on for the users they already had. That has never happened to a Chinese AI company at this scale before. And it wasn't a glitch or a marketing stunt engineered for headlines. The kind of thing a company arranges deliberately to manufacture a sense of demand. Once you understand exactly what this model actually did, and just as importantly, what it didn't do, you'll understand why the biggest AI labs in America went quiet for a moment. By the end of this video, you'll know exactly what this new model is, where it genuinely beats the best American AI systems, where it still falls noticeably short, and why the honest version of this story is actually more interesting than the hype you've probably already seen scrolling past it online. If you want the full, unfiltered picture rather than a screenshot ripped out of context by someone trying to make a viral point either way, stick around and consider subscribing, because this particular story is nowhere close to finished. Let's start with the part almost nobody explains properly, the wall everyone in this industry keeps running into. For the last few years, building a better AI model has mostly meant one single thing: buy more computer chips, build bigger data centers, throw more electricity and money at the problem until the model gets noticeably smarter, following a pattern the industry itself calls scaling laws, where performance reliably climbs as long as you keep feeding it more raw compute. That approach genuinely works, but it's brutally expensive, and it depends entirely on having access to the most advanced chips on the planet. The kind manufactured using cutting-edge lithography that only a handful of companies worldwide can even produce. American AI companies have that access. Chinese AI companies mostly don't, cut off from the newest generation of training hardware by a wall of export restrictions that has only tightened further with each passing year. The United States has spent years restricting the sale of its most powerful AI chips to Chinese firms, specifically hoping to slow down exactly this kind of progress. Treating computer access as a choke point the same way it has with advanced chip-making equipment more broadly. For a while, it genuinely looked like that strategy was working. Chinese labs stayed a step or two behind the leading American models, and that gap seemed to be holding steady year over year, giving policymakers in Washington real confidence the approach was succeeding. But here's the part a lot of people miss entirely. When you genuinely can't solve a problem by throwing more resources at it, you're forced to get clever instead, out of necessity rather than choice. And that's exactly the position a Beijing-based company called Moonshot AI found itself boxed into. Moonshot didn't have unlimited chips sitting in a warehouse somewhere. They didn't have anything close to Silicon Valley-sized budgets to work with. What they had was a relatively small team of researchers who had to make every single unit of computing power count, because there simply wasn't a backup plan of buying more hardware if the approach didn't work. So instead of just building something bigger, they built something meaningfully more efficient instead. And on July 16th of 2026, the company released what it called its most capable model to date, Kimmy K3, timed deliberately to land just ahead of the World Artificial Intelligence Conference in Shanghai. Picture a neural network with 2.8 trillion individual parameters, roughly the scale packed inside Kimi K3, making it the largest publicly available AI model ever released anywhere in the world. Moonshot describes it as a mixture of expert design, meaning that out of 896 separate specialized subnetworks built into the model, only about 104 billion parameters actually activate for any single question you ask it. Open weight is the key phrase attached to this release, and it matters considerably more than it sounds at first. Most of the biggest AI models in the world today, the ones built by OpenAI and Anthropic, are closed systems. You can use them through an app or a website, but you can never actually see how they work underneath the surface. And you definitely can't download the full model and run it on your own hardware. Kimmy K3 was built differently from the ground up. Moonshot built it, and then committed to handing the underlying keys to almost anyone who wants them. Developers, researchers, and businesses anywhere in the world would be able to download it, inspect exactly how it works, modify it, and run it on their own servers without paying Moonshot a single cent in ongoing licensing fees. Think of it roughly like the difference between renting an apartment and being handed the complete blueprints to build your own house instead. One arrangement gives you somewhere to live. On the other hand, you have the entire toolkit to build whatever you want with it. The model can also read and process up to 1 million tokens in a single conversation, which roughly translates into being able to work through a stack of documents several hundred pages long and still keep track of every relevant detail buried inside it. At the Shanghai conference where all of this launched, China's own president stood on stage and specifically made the point that AI development shouldn't be, in his words, a solo performance by one country, but a shared effort across many nations. That's as much a political statement as it is a technical one, and we'll circle back to exactly why that framing matters a little later. For now, just hold on to the headline number. 2.8 trillion parameters given away for free to essentially the entire world once the weights actually finish rolling out. But a big headline number alone never proves anything on its own. The real test was always going to be how the model actually performs against the systems people already rely on every day. So let's look honestly at where Kimmy K3 genuinely wins, and just as importantly, exactly where it doesn't. Within hours of the launch, screenshots of benchmark results were flooding social media everywhere, and almost every single one of them told only half the real story, cropped and shared in whichever direction best supported the point the poster already wanted to make. Some posts claimed Kimmy K3 was now flatly the best AI model on the entire planet. Other posts claimed it was still clearly behind the leaders across the board. Both of those claims were technically true, because they were simply looking at completely different tests measuring completely different things. And neither side was being dishonest so much as incomplete. Here's the honest, complete version. Across dozens of benchmarks measuring coding, reasoning, and general problem solving, Kimmy K3 does not beat the very top American models when you average everything together into one overall blended score. Anthropic's newest flagship model and OpenAI's latest release both still score higher on that kind of combined, everything at once comparison. Moonshot has openly admitted this themselves, without spin or hedging. They are not claiming to have built the single smartest AI on Earth across every possible category, and a company willing to publish its own weaker results alongside its wins tends to earn considerably more trust than one that only ever shows its highlight reel. What they are claiming, and what turns out to genuinely be true when you check the actual published numbers, is something more specific, and honestly more impressive in a practical sense. On several individual tests, specifically the ones that matter most for real-world commercial work, Kimmy K3 actually comes out ahead. Take a benchmark called Program Bench, which measures how well an AI can write genuinely working code for real software projects, rather than simplified toy examples. Kimmy K3 edges out both of its major American rivals there. Take another one called SWE Marathon, specifically designed to test how well an AI can stay focused and accurate across a long, sustained coding session, rather than just nailing one quick, isolated fix. Kimmy K3 leads there too, and not by a small margin either. Then there's a test called BrowseComp, which checks how well an AI can search across the live web, gather scattered pieces of information, and assemble an accurate, coherent answer from all of it. Kimmy K3 comes out on top there as well. So what does winning these specific categories, rather than the overall blended score, actually tell you about the model? It tells you Moonshot deliberately optimized for the exact tasks businesses actually pay real money for every single day. Sustained coding work and information retrieval, rather than chasing the single highest number on a generic leaderboard designed to grab headlines. So the honest headline here isn't that China built the smartest AI in the world across every category. It's that China built an AI that is genuinely better at several specific, practical jobs companies already pay for constantly. That distinction matters enormously. And the fact that Moonshot is upfront about exactly where they still trail makes the wins they do genuinely have feel considerably more credible than if they'd simply claimed total victory across the board. Now here's where this gets genuinely interesting for anyone actually running a business. Because the price tag attached to all of this is what's rattling the entire industry right now. Being good is one thing. Being cheap while also being good is a completely different category of threat to established competitors. Kimmy K3 charges roughly $3 for every million words of text it reads, and about $15 for every million words it generates in response, with an even more aggressive rate of roughly 30 cents per million tokens on repeated, cached information it's already processed before. Compare that pricing structure to what companies currently pay to use the leading American models for comparable work, and Kimmy K3 often costs somewhere around half as much. Sometimes noticeably less once you factor in that aggressive discount for repeated requests hitting this same cached context. For a small business or an independent developer working on tight margins, that difference isn't just a nice bonus to have. It can genuinely be the difference between an AI-powered product that turns a real profit and one that quietly bleeds money every single month it stays live. The market noticed almost instantly. Within days of the announcement, shares in at least one other well-known Chinese AI company dropped sharply, falling by more than a quarter of its value as investors quickly realized their own pricing had suddenly become impossible to defend against a genuine open-weight competitor charging this much less for comparable work. When a relatively lesser-known startup can spook publicly traded rivals just by publishing a straightforward price list, that alone tells you the entire industry is watching this specific release extremely closely, treating it as a genuine competitive threat rather than a curiosity to admire from a distance. And this isn't some temporary discount engineered purely to win a single news cycle either. Moonshot built the pricing structure directly into how the model's own serving infrastructure handles repeated information through a caching system that separates the initial processing stage from the response generation stage across different pools of hardware, achieving a reported 90% cache hit rate specifically on coding workloads. That architecture is exactly what makes the aggressive cached pricing sustainable rather than a one-time promotional stunt, so the savings genuinely hold up even at large commercial scale. Not just inside a carefully staged demo environment built to impress reporters for one afternoon. But cheap and fast usually comes with a catch hiding somewhere underneath the surface. So let's talk honestly about how they actually pulled this off technically. Normally, when an AI company wants a noticeably smarter model, the standard playbook is throwing more raw computing power at it and hoping the extra scale simply pays off on its own. Moonshot genuinely couldn't take that path, because they didn't have the chip supply available to match American tech giants at anything close to the same scale. So their engineers were forced to solve a completely different problem instead. How do you make a model think effectively using meaningfully less raw computing horsepower per individual question? Their answer involved fundamentally rethinking how the model pays attention to information in the first place, through something Moonshot calls Kimmy Delta attention. Imagine a security guard watching 100 separate monitors simultaneously. The old conventional way was making that guard stare carefully and equally at every single screen every single second, which is exhausting, slow, and wastes enormous attention on screens where nothing important is actually happening at that moment. Moonshot's new approach, which they call Kimmy Delta attention, instead lets the model quickly skim most of the screens using a fast, lightweight glance, while still stopping to look closely and carefully at the handful of screens that genuinely matter for that specific moment, dynamically deciding on the fly which parts of a long conversation actually deserve full attention. That single architectural shift alone let them cut memory usage dramatically, and made the model roughly 2.5 times more computationally efficient than their own previous version, without needing a single additional chip to pull it off. They also built the overall model so that only a small slice of its full 2.8 trillion parameters actually switches on and activates for any individual question. Similar to how a hospital doesn't call in every single doctor on staff to treat one patient walking through the door. Only the specific specialists genuinely relevant to that particular case actually get pulled in and paid attention to at all. That combination is exactly how a model this enormous on paper can still respond quickly and affordably in practice, instead of grinding to a slow, expensive crawl every time someone sends it a question. Moonshot's own leadership has said plainly that the company knew from the very start it didn't have the luxury of simply scaling up with more hardware the way its American competitors could. So, what does that constraint actually reveal about how this breakthrough happened? It reveals that this wasn't a lucky accident stumbled into by chance. It was a hard resource limitation deliberately turned into a genuine engineering advantage. And it's a genuinely interesting technical story entirely on its own merits, separate from any broader national rivalry narrative layered on top of it. So how did the wider world actually react once all of this became fully public? Moonshot released Kimmy K3 relatively quietly, without a flashy keynote presentation or a major press event built around it, letting the raw performance numbers speak for themselves instead of a marketing campaign. That quiet confidence turned out to be genuinely justified almost immediately. Within roughly 48 hours of launch, demand had grown so quickly that Moonshot had to pause new account signups entirely, simply because their available computing capacity physically couldn't keep pace with how many people wanted to try it out at once. Existing users already signed up remained unaffected throughout, but the company publicly admitted it was scrambling hard to add more server capacity as fast as it possibly could manage. One well-known figure running a prominent AI ranking platform publicly called this possibly the single biggest release of the entire year, specifically pointing to this moment as one where a genuinely open Chinese model was outperforming closed American systems on real, independently verifiable head-to-head tests, rather than simply repeating marketing claims from a press release. Moonshot also promised something closed American labs almost never do at all: a full public release of the model's actual trained weights, essentially its entire underlying brain, by July 27th of 2026, letting researchers and companies anywhere on Earth download it and run it themselves for free from that point forward. And Moonshot did in fact follow through on that exact promise, publishing the complete 2.8 trillion parameter weights on schedule, along with a full technical report and deployment documentation, closing out what had been the single biggest open caveat hanging over the entire launch. That's the specific detail that turns this from being just one impressive product launch into something with considerably bigger implications stretching well beyond one company's quarterly results. Which brings us to the real story sitting underneath all of this. The bigger game actually being played here. This was never really about one model simply beating another model on a leaderboard somewhere, chasing a single ranking number for bragging rights. It's about two genuinely different strategies for how the future of artificial intelligence gets built and controlled going forward. And those two strategies have real consequences well beyond who tops a chart this particular week. American companies have mostly chosen to keep their most powerful models locked behind paid subscriptions and access controls, arguing that keeping tight control over the technology makes it meaningfully safer and easier to manage responsibly at scale, since a closed system lets a company monitor and restrict how its most capable model actually gets used. Chinese companies, Moonshot very much included, have increasingly chosen the opposite path instead, giving their most powerful models away for essentially anyone to use, inspect, and modify freely, accepting the loss of that direct control in exchange for a different kind of advantage entirely. Partly because that approach spreads their underlying technology globally far faster than any traditional marketing campaign ever could, turning developers everywhere into unpaid advocates simply by using the tool. And partly because open access conveniently sidesteps some of the specific disadvantages created by restricted chip supply in the first place. Since a model given away for free doesn't need to outcompute a rival, only outdesign it. Whichever broader approach eventually turns out to be the right long-term strategy, the practical, immediate effect is already visible today. Businesses, universities, and independent developers in countries with no direct stake whatsoever in the US-China technology rivalry can now build genuinely serious AI products on top of a frontier-level model without paying an American company a single dollar for that underlying privilege. That's real, lasting influence. And it doesn't show up cleanly on a quarterly earnings report the same tidy-weight chip sales figures do, which is exactly why it tends to get underestimated by anyone only tracking revenue. For years, the working assumption in Washington was that restricting access to advanced chips would keep Chinese AI development permanently a step or two behind the leading edge indefinitely. Kimmy K3 doesn't actually prove that the original assumption was entirely wrong. China still faces genuinely real limits on how much advanced computing hardware it can currently access, and Moonshot's own server capacity crunch immediately after launch proves that specific limitation is still very much real and biting in practice. But it does prove something else worth sitting with carefully. That a country working with meaningfully fewer hardware resources can still close a substantial gap through smarter underlying engineering, even when it genuinely cannot outspend its rivals on raw compute. That's a considerably harder problem for policymakers to solve cleanly using export restrictions alone, since restricting hardware doesn't restrict the underlying research talent finding smarter ways around the constraints. And it's exactly why people who study this specific space professionally are calling this one of the most significant AI releases of the entire year. Not because it changes absolutely everything overnight in one dramatic moment, but because it meaningfully shifts the trajectory going forward. It's worth being honest about the model's own acknowledged limitations here too, rather than only presenting the highlight reel and letting the wins speak for the whole story. Moonshot itself has openly acknowledged several specific areas where Kimmy K3 still falls short of the closed frontier leaders, a level of self-disclosure that's genuinely rare in an industry more accustomed to marketing copy than candid limitation lists. The model shows real sensitivity to how its own internal reasoning history gets handled, meaning that certain agent setups which truncate or modify its chain of thought partway through a task can cause a noticeable drop in output quality compared to leaving that reasoning trail fully intact. It also tends toward what researchers describe as excessive proactiveness in ambiguous situations, meaning it will often simply act on its own best guess, rather than pausing to ask a clarifying question first. A common trait in this style of specialized mixture of experts model, where individual expert subnetworks can overfit toward taking action rather than seeking more information. And despite genuinely matching or beating rivals on hard, measurable benchmarks, the subjective, day-to-day conversational experience using the model still trails the most polished closed competitors in overall smoothness and polish. The kind of gap that doesn't show up on a scoreboard, but that users notice immediately in casual back-and-forth conversation. So what does that honest self-assessment actually tell you about where things genuinely stand right now? It tells you this is a real, credible technical achievement with real, specific, acknowledged limitations, not a flawless replacement for every closed model on the market, and treating it as either extreme would be equally inaccurate. If a completely free OpenAI model can already match the biggest paid systems on the specific tasks that matter most to your own actual work, would you genuinely switch over to it? Or does paying for a familiar, established name still feel worth it to you personally? And one more thing genuinely worth sitting with before you go. A year earlier, most people entirely outside the AI industry had never once heard the name Moonshot mentioned anywhere. Now their model is being compared benchmark by benchmark directly against the two most talked about AI companies on the entire planet. And holding its own on the exact tasks businesses actually pay real money for every single day. That kind of jump in relevance doesn't happen slowly over years. It happens in a single announcement on a single stage, and then the entire conversation shifts practically overnight. If this video helped you actually understand what happened here instead of just reacting to a scary or overhyped headline somewhere, hit subscribe so you catch the next one. Because this particular story is nowhere close to being finished. Drop your honest answer in the comments section below.